Okay, in this video we're going to link the method of extraction to the reactivity series of metals and how those two can support our understanding of this. Okay, so we've looked in a little bit of detail at aluminium and extraction of iron, but here is the full reactivity series, and you can see for reference we have carbon in here, which is a non-metal, but it's in there just to help us understand why it's important. Okay, so think about the reactivity series broken into three parts. Let's deal with the bottom part down here. These metals here are very unreactive metals, therefore we discover those in the earth crust as uncombined. So if you find a piece of gold, it's just gold, it's not gold oxide, it doesn't join with anything because it's an unreactive metal. So they're quite straightforward. We find them and we can take them as the elements when we discover them. This next group are more reactive. Okay, so we've talked about iron. Iron is found on the Earth's surface as iron oxide because it's a reactive metal, and therefore to get the iron from the iron oxide we have to go through a process of extraction, and to do that we're going to use carbon because carbon is more reactive than iron and therefore it can displace it from the compound, forming carbon dioxide and just the iron. So any of these metals that are below carbon are all extracted using carbon, and the carbon will reduce, remember that means remove the oxygen from these compounds. This makes it quite cheap because carbon is not an expensive process, it's quite quick and simple to do, so it's quite a cheap process, and obviously that impacts on the cost of these metals because the cost of processing is going to be less as well. As you go higher up, we then got a little problem because these metals are all above carbon. So you can see here we talked about aluminium previously. Aluminium oxide is contained in bauxite. We can't react carbon with aluminium oxide because carbon is less reactive than aluminium and will not displace it or reduce it, remove the oxygen from it. So how do I do this? Because these metals are more reactive, we have to undergo electrolysis. Electrolysis, remember, means breaking down the compounds into the elements. So aluminium oxide would become aluminium and oxygen. This is a more expensive process, it takes a lot of energy. We use electricity for the electrolysis itself. We have to make these molten so that they will break the lattice apart, the ionic lattice apart, and the ions can move and therefore will conduct. That requires energy as well. Okay, so the reactivity series is in effect three parts. Most reactive elements are all extracted by electrolysis because they're above carbon in the reactivity series. The next bunch are reactive metals but not as reactive, and they're all below carbon in the reactivity series, so we can use carbon to reduce those, and the bottom ones are just found as elements because they are unreactive elements and we just find them as the uncombined element in the Earth's crust.